Okay, so the first thing that we're going to learn today is how to describe a distribution. So there's a couple things that we need to learn about a distribution so that we can learn how to describe the distribution. So I put that language in quotes because that is typically what is stated to you or put in the question. They say, describe the distribution. Okay? And if they say describe the distribution, you will describe the distribution with your socks. So that's why you guys are wearing your silly socks today, so that you can describe the distribution with your socks. All right, so we're going to learn what that means. The first S in socks refers to the shape of the distribution. Okay? So the shape of the distribution is the first thing that we need to talk about. And when we talk about it, we'll write the word shape, and then we'll say what that shape is. So we want to use words like symmetric, uniform, skewed left, skewed right, unimodal, bimodal, multimodal. And I have on the back of this paper, on the next page, page 17, I have some examples of those things. So let's take a look at that. Turn to page 17. So we could say that this first shape here, if you are wearing a uniform, then everybody is wearing the same thing. And so in this case, uniform would mean that every event is happening the same amount of times. So that is uniform, so all the bars are straight across. Okay. It also would be considered symmetric. And then yesterday we did talk about what makes something skewed right. Skewed right means it is stretched to the right. That's the best way I can get people to remember that. Skewed right is stretched to the right. Okay? And then our next one, here's a symmetrical distribution. This we would also say that, well, we'll go back and do that in a second. This next one is skewed left because it is stretched out to the left. Stretched left. Okay. So what? There's many ways it could look. I'll tell you something more about that in a second. Okay, this next picture is bimodal. So let's talk this modal thing. Modes, what do modes mean? Most often. So in order for something to be the most often, then it is the highest bar. Okay, because you have the most items in that bar. So most often is going to be your mode. So in this case, we really kind of have got two sections that have a mode. This is considered bimodal because it's got two modes. Most of the times, we deal with something that's more unimodal. Unimodal would have how many modes? One. So you can see up here, this one is also unimodal. So it should have the two words skewed right and unimodal to describe it. This next one, symmetrical, is also unimodal. And so is this skewed left one. Correct. The unimodal is symmetrical even though it has these two bars because it's right there in the same section. It would look like this to have stuff that is bimodal. In fact, you could even have something, let me see if I had a picture. Okay, you could even say something like this is bimodal because we've clearly got two different kinds of things going on here. It could be such that these are the females' shoe sizes and these are the males' shoe sizes, and you just had more females than males, or something like that. Okay, so your bimodal could also look like that. Yes, ma'am? It can go more than two, and that would be called multimodal. So more than two would be multimodal. Here, we've got this and this going on. This is not my favorite example of that, but because we don't want to get like too into it and just go off and say, well, everything's multimodal if it doesn't have, if you just have stuff all over the place. but we'll name some and you'll get better at it. Okay, so let's practice these. Oh, I should have numbered them or something. Okay, this top left one, what are you going to say? There's two words to describe this. Skewed left. And what else? Unimodal, good. Okay, how about this one in the middle? Okay. Symmetric and unimodal, good. Okay, this next one here. Skewed right. And unimodal. Okay, good. All right, next. Yeah, I'm going to say bimodal and skewed left. Okay, what do you say about this one? Good. Multimodal, symmetric. Good. And then this last one. Bimodal, okay. Very good. Okay, nice. So that's the kind of language that you use when you describe a distribution's shape. Okay, that's the first thing with our socks. Describe a distribution's shape. All right. The second thing in socks is if there are any outliers. All right, and we've got one rule that we know about how to tell the fences. You remember how we would tell the fences with the box plots? What would be, for box plots, what were our fences? Q3 plus 1.5 IQRs is an upper outlier, and what was the other one? Okay, good. So this is one way to tell if there are outliers. If you have a box plot or you're using the median, if you're using the median to describe stuff, you would use this. Okay, and I don't recall if I talked about this when we did standard deviation. I think I might not have. But there is a rule for using standard deviations, and it is this. The mean plus 2 standard deviations is a, let me rewrite that. So the mean plus 2 standard deviations is an upper fence if you have the information with the mean and the standard deviation. So if you have mean and standard deviation stuff and you choose that rule, then mean plus 2 standard deviation is that upper fence. So if there are data above that, you have outliers. Okay, this is not the number 20. This is 2 sigma, because this sigma, this is a Greek letter sigma, represents standard deviation. Okay, so please do not think this is mean plus 20. No, it's mean plus 2 standard deviations. Okay, and likewise over here we have mean minus 2 standard deviations, and that is your lower fence. And anything below the lower fence is an outlier. Okay, very good. That's outliers. Okay, socks, shape, outlier. Next is center. So the center you will use is pretty much your mean or your median. Okay? And we have kind of talked about when it might be better to use a mean or when it might be better to use a median. Do you remember on our last assignment that we had done together, we found that mean got affected by outliers or skew. So if you have skew or outliers, don't use the mean. If you have skew or outliers, you want to use the median as the center that you use. Okay? Does that make sense? And we have that same kind of thing happening with spread. Spread is how stretched out your distribution is, how closely clustered around the mean, how squinched together, how varied. Spread has to do with how varied it is. Okay, we've been talking about that this year. So the key, typically you will use interquartile range or standard deviation. But if you recall the other day when we did a standard deviation and we had an outlier of a Prius that had 44 miles per gallon, what did it do to our standard deviation? The Prius that had a way high miles per gallon. It increased. It changed the standard deviation. So the standard deviation is also affected by outliers. So if you have outliers, what should you use? What spread should you use? Median and IQR. So let me summarize that. And you might write this down at the bottom. Okay? So if you have skew or if you have outliers, then you need to use your center will be the median, and the spread that you use will be the IQR. If you have skew or you have outliers, you should use the center, the median for your center, and IQR for your spread, because those are resistant. What does it mean to be resistant? Good. Median and IQR are resistant. They are not affected. Okay? So, likewise, if you have symmetry, then you're good to go. And if you have symmetry, then the center that we want to use is mean. And the spread we want to use is standard deviation. Okay, so if it's symmetrical, then you don't have things affecting your information, so we want to use mean and standard deviation. And no outliers, by the way. Okay, I have a song for this. Okay, so let's listen to that. Let's finish. Let's finish all the information about our socks. Okay, so we know that when we describe the distribution, what are the things that we do? Shape and outlier, center and spread. Okay, there's that. How do we know when we should choose median and IQR? What would your shape look like such that you need to choose median and IQR? Yep. If you have skew, then you should choose median and IQR. Okay, good. How about mean and standard deviation? Good. Symmetry, standard deviation, and mean. Okay, so we are moving on to page 18. I think I'm done. Oh, now we'll talk about that later. Okay, so let's come here to page 18. And we're going to do one of these together, and then you will do the other three. All right? So here we go. We're going to do this top left problem. So the first thing that I want to look at is I kind of see, okay, what's the first thing? I'm going to describe this distribution. I think that's what the instructions say. Describe this. So I'm going to use my socks. So what's the first thing in my socks? So I want you to write shape. Okay. So what is the shape? Skewed left. And unimodal. Good. Okay, good. No. So what's next? After shape, we do outliers. Okay, we're going to have to figure out if there are any outliers. There might be. It kind of looks like there might be, but we know how to compute this. Let's talk about that in just a second. Let's get to that. Let's talk about center and spread. Since we have skew, we must choose to use IQR. Yeah, that's right. If you have skew, then you must choose to use median and IQR. Okay, so we're going to use the median and IQR. So our center is going to be described as what value? Can you see this list of data over here to the left? So what is the median? Good. So we will write median is 94. Do not just put 94. What's 94? Mean or median? Okay, so you have to say median is 94. And for spread, what do we use for spread? Yes. If you have skew, then you must choose to use median and IQR. So we will say the IQR is, and we got to calculate it. Got to take my Q3 and subtract my Q1. So 97 minus 86 is 11. Okay, very good. So since median and IQR are the center and spread I choose to use, then what way should I check for outliers? Should I use the box plot, the IQR method, or should I use the standard deviation method? I should use the IQR method. So let me do a little quick review up here. For outliers, I'll just kind of summarize this for you, and we'll actually practice this tomorrow. If you choose to use IQR method, then you're going to do the Q3 plus 1.5 IQRs and Q1 minus 1.5 IQRs. Okay? However, if you choose to use the standard deviation method, okay, then you have mean plus 2 standard deviations. This is not a 20. This is a standard deviation, a sigma. And the lower fence will be mean minus 2 standard deviations. Okay? All right. So which are we dealing with on this one again? The IQR fences. Okay. So we're going to calculate those. I'm going to come up here and kind of do that. My upper fence, I'm just going to kind of make myself a note. My upper fence is going to be 97 plus 1.5 times 11. And somebody's going to calculate that for me. My lower fence will be 86 minus 1.5 IQRs. Wait, what's the upper one? Oh, for that, well, you add that to 97. Who's got that for me? 113.5, okay. And then what's my lower fence? I think it's like 70-ish or something. 69.5. Okay, 69.5. Okay, so look here. Do I have any upper outliers? My fence is way up here at 113. Lower outliers? Somewhere in there is my fence. Do I have any lower outliers? Okay, then here for outliers, I'm going to put lower outliers below 69.5. So anything below 69.5 in my data set is a lower outlier. All right, that is the way that you describe the distribution. Okay? And calculate the one that you need to know. So I'm going to have you now work the rest of the class on the next 3. Let's kind of talk about this one. It is not perfectly symmetrical, but I'm going to tell you the intent for this one, that it was intended to be symmetrical. So what measures of center and spread should you use on a symmetrical distribution? Yes. Symmetry, standard deviation, and mean. Okay, so if you have symmetry, use standard deviation and mean. All right, and then you're going to do those bottom ones. Okay, that is your assignment to finish today, is those 3 distributions to describe.